Hello everyone, and welcome back to part 3 of our Getting Started tutorial for fluid solid heat transfer simulations in Ansys Discovery. In part 1 and part 2, we set up, solved, and post-processed some of our initial results here in our Explorer mode, which utilizes our live GPU-based solver. In part 3, we'll be utilizing our refine mode, which uses our Ansys flagship solver of Ansys Fluent. So let's go ahead and get started. The first thing we need to do is to navigate to our refine mode. We can do this by going to the bottom center of our screen, identifying the word Explore, and then clicking the arrow to the right. After clicking this, you'll see that the word Explorer has now changed to Refine, indicating that we changed to our Refine mode. You'll also notice on the left side of the screen that we have all of our important information from our Explore mode transferred into our Refine mode. This includes our physics boundary conditions as well as our materials. There are a few differences between our Explore and our Refine mode, so let's go ahead and cover some of these differences now. One important requirement of our Refine mode is that you need to imprint the geometries onto one another, meaning that one face on one body can only interact with one face on the other body. So in this application, if we hover over the top surface of our cooling plate, you can see that this singular face is interacting with each of these IGBTs. So we need to go ahead and split this face into an individual face underneath each of these IGBTs, and then the last one will be a remaining fourth face. We can do this by navigating up to our Prepare tab and choosing this imprint function. It's in the same group as our volume extraction tool that we used in part 1. Let's go ahead and click this now. As you can see, it identifies the edges on the outside of our IGBT, indicating that these will be imprinted onto the top of our cooling plate geometry. Let's simply click this check mark now. If I hit escape 2 times to close our heads-up display, we can right-click on our geometry and choose Hide. As you can see, we now have an independent face directly underneath each of the IGBTs, and we have this remaining fourth face here. Let's go ahead and right-click and Show All. Let's go up here to the top again and navigate back to our Simulation tab. The Refine mode, utilizing our Ansys flagship solver of Ansys Fluent, has a few more options compared to our Explore live GPU solver. For instance, if we take a look in our ribbon now, we have access to our global and local sizing controls. This is the Ansys workbench meshing methodology. As you can see, I can control global controls that control the meshing on all geometries, or I have the opportunity to go ahead and apply local refinements. Specifically, this puts mesh controls on individual bodies or faces that you select. For the sake of example, let's just go ahead and utilize a local refinement to change the mesh size on this body. So I can click on local refinement, triple click to select my cooling plate geometry, and for the sake of example, let's enter a mesh size of 3 millimeters. More of this meshing is covered in our in-depth tutorials for our fluid simulation. So if you need more information, please be sure to review those. As you can see, after I entered a 3 millimeter sizing, it's now assigned in our tree as a fidelity adjustment. Let's hit escape 2 times to close our heads-up display. In addition to our ability to create local and global mesh controls, we also have some advanced simulation options. Once again, these are covered in our in-depth tutorials, but it's important to highlight that they are here. In our additional fluid flow options, you can see we have the ability to control our modeling method or our turbulence model, and we can also control our convergence settings. These will be covered in our in-depth tutorials, so please be sure to review those. One important step before we solve our simulation is to create a monitor on our inlet of our flow region. This is often used to judge convergence of our solution. So let's go ahead and create a monitor on our inlet face. If we go ahead and navigate down to the left side of our screen to the bottom left, we can highlight the face that is associated with our inlet. As you can see, it's this face here. So let's go ahead and create a static pressure inlet monitor so that we can use this to judge convergence. Let's go ahead up to the monitor section, click this arrow for the drop down, and choose custom. From here, let's select our inlet face, choose our variable as static pressure, and leave it as average, and click this check mark to confirm. As you can see, I now have access to details. So as the simulation and solution goes through its iterations, we can track the value of this average static pressure at our inlet. Given that the rest of our conditions have been applied in our Explore mode and directly transferred into this Refine mode, we can begin to solve our simulation. Let's go ahead and click this in the bottom right corner. One important thing to note is that our refine mode utilizes the CPU and RAM on your machine to solve, so the solution will take a bit longer to generate here. One important thing to note is how the colors change around our simulation information display. As you can see, it is a majority yellow with a small portion of green. The filling of the green indicates the status of our simulation. Typically, when it gets about its halfway point, you're able to see your mesh. If we go ahead and go to the right side of our screen, right next to our Solve button, you'll see this Show Mesh button. If I click this, we should begin to be able to see our mesh. Sometimes there's a slight delay as it is still generating our geometry. As you can see here, we have a very nice clean mesh on the majority of our components, and we can see that we have a local fidelity adjustment controlling the size of our mesh on this cooling plate, roughly keeping things pretty uniform. Let's go ahead and rejoin after the simulation completes solving. But while we do this, let's go ahead and open up our static pressure and click our details so that we can begin to track the values here as we go through our iterations. Let's rejoin here in a few minutes when the simulation is complete. Now that the simulation has been completed, we can begin to post-process our results. Let's first take a look at the details for our average static pressure monitor, which was assigned to our inlet face. If we hover over this details plot, we can see the values for the average static pressure with respect to each iteration of the solve. You'll notice that the values begin to flatline at the later iterations, which is traditionally an indication that the simulation is converging. Let's go ahead and take a look at our max temperature monitor here. You'll see that we can also look at the values that were calculated in Explore, and these are the orange ones, as well as the value that was calculated in Refine, which is our purple one here. Taking a look at our results arc in the bottom right corner, you'll notice that we have very similar options to what we had in our Explore mode. We can access things like vectors, streamlines, particles, and so forth. Let's go ahead and take a look at our saved scenes that were created in our Explore mode. Clicking this arrow here allows you to see the scenes that were saved. Clicking these will go ahead and reorient the geometry as well as change the variable that was shown in the original save scene. One last thing that I'd like to cover here is our transfer to our Ansys flagship product of Ansys Fluent. If you wish to transfer this simulation to Fluent for further work, you can go ahead and transfer this clicking this button here. It will go ahead and transfer your mesh, your materials, and your physics boundary conditions. Thank you for watching this Getting Started tutorial for Fluid Solid Heat Transfer simulations. For more information, please be sure to review our in-depth tutorials. Thank you and take care.